So today we will be focusing on Industry 4.0, how ESG and 4.0 are merged together, especially in terms of data-driven and AI-driven landscape. Okay, so let me introduce myself. My name is Imran. I am basically the CEO of Datalytica Sdn Bhd, and I have 19 years plus experience in industry, working in a different part of the world, including Malaysia, Thailand, Indonesia, Philippines, Middle East. And I was also honored to serve under under government agencies on the technical advisory role, and also universities like DRB Highcom University, as well as Pradana University, NTW University as well. Okay, so we will be discussing ESG for Industry 4, how ESG is merging with Industry 4.0 to have a compliance and standardization that brings a lot of benefits, including standardization, including people transformation, including operating cost reduction, which is ROI, and RODI, which is return of digital investment. Uh, I have given consultancy basically to many organizations, uh, which includes basically manufacturing and automotive sector as well, and also construction as well, in which my my role was on the digital side in terms of people transformation, technology stack selection, and also solution architecture. So before we proceed with the ESG, let's discuss about fourth industrial revolution, Industry 4.0, and digital leadership. Because in a minimum capacity, you as a leader needs to lead yourself. So in the first industrial revolution, we were having uh, we were having mechanical and steam as a part, where mechanical can able to use for production equipment, and where the core element was steam. Electrical evolution was happened second revolution, which is on the 18th century, where mass production was being introduced as a concept that was successful throughout different parts of the world. And the core element was electricity. Electricity not only light the homes, but also light up the factories, where there was a mass production. And Robert Ford basically played an important role. Industry 3.0, or third industrial revolution, was on internet, network, automation, production, chips, PLC, SCADA system, and the core element was oil for the energy production. And fourth industrial revolution was on digital revolution, where data is the new oil, and data is basically transforming the industry in terms of autonomous ecosystem. So when we talk about data that has been produced by cyber physical system, or IoT, and robotics, and then it is transferred to cloud, where it has been stored and accessed, analyzed, and AI will be using those clean data to basically make a decision, which can be in the form of two. One is the predictive analytics and prescriptive analytics, which is actions. So in a factory of Industry 4.0, there are different technologies basically working together to make this factory smarter. So we have cyber physical system. We also have IoT, which is Internet of Things. So IoT is devices, machines, or sensors that can connect with the internet, can send data or receive data both, but real time. We have an autonomous system in the factory, where there are robots or vehicles bringing the different parts. We have a cobot or robotics, collaborative robot, that are basically doing the automation tasks, low value tasks. So it's quite popular right now in the industry, and it's not that much expensive. 10 years back, it cost a fortune, but now you can easily get a cobot for 6 to 8,000 US dollar. And then you are having a nanotechnology, neurotechnology, advanced materials for your production line. And one of them is basically 3D printing, which is called additive manufacturing. So additive manufacturing are basically contributing towards ESG as well. How? Because it is added, and it is, you know, having a less wastage. So it's quite lean. So in this case, uh, lean is basically a concept in a factory that focus on how we can reduce the waste. So reducing the waste will impact the environment, and they are basically um, part of compliance for the ESG as well. And then sensors. So all those physical system or technologies are basically sending to the cloud. Cloud is basically store their data, and after the data is being stored, then it is basically analyze the data, which is analytics. We will study later for the 4.0 part. And also for those analytics, we are giving the refined data to artificial intelligence that are basically creating the whole ecosystem autonomous. So every technology is contributing towards ESG, and later on we will able to know about that one in the more details. So the presentation today will be focusing on technologies 4.0 and then ESG and how they are combined together to create an ecosystem of sustainability. I have added and then we can do a Q&A session before we conclude our program today. So, so this is the ecosystem in terms of technologies that are communicating with each other in a harmonious fashion to create the ecosystem more autonomous, but at the same time, they are also contributing directly or indirectly with the ESG. So these are the some technologies that are basically performing in the making the factory more autonomous and also contributing, and we will know how. So in ESG concept are basically more on sustainable ecosystem uh, in align with sustainable development goal. Okay, so UN have a sustainable development goal, which is no poverty, zero hunger, good health and well-being, quality education, gender equality, clean water and sanitization, affordable clean energy, economic growth, industry, innovation, infrastructure, which is 3I, reduce inequalities. 11 is the sustainable cities and communities, responsible consumption and production, climate action, life below water, life on land, and also peace, justice, and strong institution. And at the end is on the partnership for the goal. So sustainability is not a new concept. It's a quite old concept, which is development that meets the need of the present without compromising the ability of future generation to meet their own need. So in ESG, which is environment, social and governance, we are basically focused on how environment can able to affect the objective of economy and consideration for a company to contribute to GHG emissions, deforestation, biodiversity, waste management, pollution, energy efficiency, and renewable energy. Because energy is something which is very precious. Now, 20 years back, when we were using cell phones like Nokia, our energy needs were limited. But now everyone is having a smartphone that they have to charge every day, maybe one or two times. They may have a tablet, they may have a laptop, they have multiple devices, and those devices need energy. So we need to have a sustainable ecosystem where we can have an energy efficiency and renewable energy compliance ecosystem to to follow the standardization for ESG. So ESG is about companies. It's not individual only. It's basically organization level initiative, which is to respond to the climate change, treat their workers with dignity and respect, build trust and foster innovation and manage their supply chain. Okay, there are benefits of the ESG as well, which is in align with SDG goal to generate at least US 12 trillion worth of market opportunity by 2030, 50% of the valued business opportunity in a developing country, and creating 380 million jobs by 2030, almost 90% of which will be in developing countries. Okay, but there are some challenges and issues. For example, lack of awareness is one of them, where people are not aware of the how ESG and technologies of fourth industrial revolution can combine to assist organization towards ESG goal. Number two is on difficulty in understanding and managing the ESG risk and quantifying the ROI and RODI. Number three is on training adoption technology, which may cost additional to MSME. And then number four is a mixed bag of competing standards and frameworks. So there are a lot of standards and certifications, which I will not be going to because I'm not representing any of the certification body here. But definitely, those certification can help you getting a incentive from the government, especially from MITI and also mostly Dalam Malaysia. And then last is about international standards are quickly changing because technology is changing that is affecting the compliance of the standardization across the globe. So there is a challenge that with the rapid evolution of technology, need economy. So how we can able to catch up that pace, fast pace, to have a compliance for sustainability and also for ESG. So sustainability is something which is really crucial for any organization in general. So when we talk about ESG as important aspect, so ESG data universe is basically having lot of attributes. So those attributes can be in terms of environment, where you have a biodiversity loss, climate change, renewable energy, reduce carbon. So let me explain one by one. Climate change, how we are basically affecting the climate change. Right now, there are EVs on the market which are contributing towards climate, pollution reduction. And then there are also renewable energy using solar panels or wind that can have a need of energy reduction blueprint. Also, reduce carbon emission, green building, deforestation, native title, pollution, and also reduced waste. So these are all of the attributes for E. On the social, which is on diversity, inclusion, and race, gender, how they can be a harmonization, how they can be a harmonization about different nationalities or different races, so they can able to work together using their creativity, combine together, and then move towards organization goals as per the corporate roadmap. And then human rights and modern slavery compliance, supply chain, anti-discrimination, bullying, harassment, First Nation people, culture, heritage, and also health and safety and data privacy. So these are basically based on the S part. On the G part, it's on risk mitigation, shareholder activism, anti-bribery corruption, accountability, board independence and diversity, and decision making along with the leadership. So what really interesting that we will be talking in detail because it's a very big topic is number one on renewable energy, how we can able to reduce the energy blueprint. Number two, we will be looking into data privacy. And number three, we will be talking about leadership aspect of decision making, which is data-driven decision making today. So ESG have an evolution also. So evolution ESG 1.0, so sustainability 1.0 was on the keep the plant running and maximizing the output and reduce the energy blueprint, inputs, and basic safety and security. So that was basically the standardization for ESG 1.0 process. ESG 2.0 was sustainability 2.0, more focused on efficiency. So ESG 1.0 was on productivity, 2.0 was on efficiency, how we do things right. Instead, how we do things right from the beginning. And then value chain scope or visibility. So visibility of the value chain or supply chain it means that they are IoT enabled end-to-end ecosystem that is producing the data. So you have a control tower application solution where you are having a visibility of not only currently what is happening end-to-end in supply chain, also descriptive analytic, what had happened in the past, and also what can happen in the future. Life cycle view, how we can able to have a product life cycle view using data-driven landscape. Resource optimization. So resources optimization is not only in terms of energy, but also materials in the factory, also time, and also energy, and also people. How we can able to increase the people optimization or productivity increase. Circularity, design of X, which is DFX, the design of any product. Cost reduction, because when you are implementing those technologies, your goal is to reduce the cost, reduce the time, and reduce the energy. And how we can able to have a minimized waste on based on the lean aspect of things, which is called digital lean or lean 4.0 in a manufacturing, and also compliance and standardization in terms of communication, in terms of technology, in terms of different standards, maybe from ISO or others. ESG 3.0 was basically on more on responsibility. Do the right thing. So do things right was in 2.0, but do the right thing approach was basically one of the important aspects for 3.0. Triple bottom line, shareholder value, protect the brand, incremental improvement. This incremental improvement is more on agile incremental improvement, which is basically on the continuous learning and continuous improvement approach in an organization, but based on agility of an organization using the principle of agile, which can be agile scrum, kanban, scrumban, or even beyond. CSR reporting, reports on impacts to the environment. And lastly, for ESG 4.0 is next gen sustainability, which is transformation. Step change improvement means that small baby step towards the right direction is better than one big step in towards wrong. Industry 4.0 tech enabled means that you have an IoT enabled ecosystem, your machines, your sensors, your infrastructure are hyper connected, and they are basically controlled using real-time environment of the factory. So dashboard will tell you about real-time aspect of your factory health based on the asset productivity, and also the visibility of descriptive and predictive analytics. Okay. So ESG framework was being formed. There are many frameworks to enable ESG 4.0. And then also purpose-driven strategy in terms of people, process, technology, data. And then business model shift, because 4.0 is more on data-driven aspect. So 3.0, you have a mass production, but 4.0, you are basically on-demand based. So you don't want it to have an inventory holding cost. Risk-based innovation means that you would like to have AI-driven innovation. Means that innovation using digital design thinking principles and also agile to re-innovate things in a better way by taking help from the data and also AI and transparency disclosure. So transparency in the factory is based on the real-time data. So using blockchain technology, for example, you cannot tamper the database data because it's decentralized, and the tokens of the security has been changing rapidly. So it's really impossible to tamper the data in the blockchain-based ecosystem. So in the blockchain, you can able to have a private, permissioned, or permissionless ecosystem. So organizations use the private blockchain to have a compliance. And using blockchain, you can able to have a traceability aspect of the things as well for your supply chain visibility, which is in compliance to ESG initiative, especially on the data privacy. A last report on the impact for the ESG risk. Okay, so this is the evolution, and ESG is not basically there's a specific team for that, but in most of the companies, it's a company-wide approach or company-wide initiative, and to develop a culture of a company following the ESG. So they may be HR will be involved, product teams, and other teams. So that, for example, employee engagement, diversity and inclusion, ERG, volunteering, employee philanthropy is contributing to the ESG point and strategy towards overall aspect of an organization. Moreover, they may be travel on-site virtual facility energy efficiencies are also contributing the measurement of ESG as part of a strategy. Your material handling, where you are optimizing the use of materials and also materials that are more towards less carbon emission. Your optimized packaging for recycle materials, your supply chain resilience and transparency, and the shipping to the customer with the IoT as well as analytics and AI ecosystem for your product development can also contribute towards your ESG goal. Lastly, on the power and environment impact, how you are sourcing the energy, consuming the energy, and how you are optimizing the new energy. So one of the biggest problem is that people blindly use solar panels. That strategy is not good. What you need to look into in an organization is by installing an IoT sensors and understand the energy usage of different areas of your factory or industry. That may take a couple of weeks. So you need to see from the descriptive analytics point of view about the energy consumption, number one. Number two, which of the areas that you can able to optimize and control the energy. So that will be your second step. And the third step is basically enable the IoT control in the environment. So previously you're only harvesting the data from the IoT for the energy usage, but now you're controlling the environment. For example, you can put proximity sensor. When someone must or enter inside a space, then it can able to on the lights. And when they leave, then they can off the light. That can be implemented in the common areas, stairs, toilets, and so on, and even in parking. Because if you come across at night in KL and other places, you will be able to see it in a lot of condominiums or a lot of industry. The parking is empty and the light is on for whole night, which I think is really utilizing the or wasting the energy. But for those common area contribution, maybe 5 to 10%. So 5 to 10% quantification if you have a big factory or medium-sized factory with a 1 million ringgit of electricity bill, so 10% will actually saving 100K per month. But if you want even more, then this means that we have to utilize how we can able to use other aspect of energy consumptions. So from there, you can able to have a predictive analytics of your energy use. That how if you reduce it, how much saving you can able to have. Even 5 to 10% will make a difference in terms of quantification. Then you can able to install the solar panels because you have done the optimization already. So you save energy 5% to 10%. And then moreover, after installing the solar panels, then you can able to reduce even more. Means that you can able to save even more energy because some of the energy is using from the natural resources. So first is energy saving strategy, then energy renewable strategy. So it will end up saving more than 10, 15, or even 20%. So in the end-to-end IoT ecosystem for the technology reference model that can be implemented in automotive, manufacturing, supply chain, even other sectors, where we have a hardware layer, communication level layer, software layer, and also application layer. So on the hardware layer, we have different IoT sensors, which are humidity sensor, vision sensor, pressure sensor, motion sensor, temperature sensor, force sensor, acoustic sensors. We have a communication hardware, which can be wireless, USB-based, PLC, Modbus, gateway, machines. Actuators, electric, hydraulic, pneumatic, mechanical, processors, and all the other PCBs, hardware, and batteries. They are basically termed as the hardware layer in the Industry 4.0 ecosystem. Okay. Now, those hardwares are IoT compliant. So they are sending the data. But before they send the data, they have to communicate or connect with the network. So usually the classification for the networks are four. One is wired, another four are wireless based. So for that wireless based, they can be short range, low bandwidth, short range, high bandwidth, long range, low bandwidth, long range, high bandwidth. So short range, low bandwidth means they are short range, couple of meters. And low bandwidth means that they can transmit small data, text data numbers. So RFID, NFC are the example of short range, low bandwidth. Short range, high bandwidth means although they are a couple of meters, maybe 20, 30, 40 meters of the coverage, and you can transmit bit bigger data like videos and images. So Bluetooth, Wi-Fi, Zigbee are some of the example of those technologies over here. Then in in the long range, low bandwidth means that the range may be a couple of kilometers, and low bandwidth means they can transmit IoT small data. So Sigfox, LoRa, NB IoT are the example for that. And then long range, high bandwidth means that they are range is couple of kilometers, and you can transmit big data like videos, images, sound. So 4G, LTE, and 5G are the example for that. So these are wireless based. And then you have wired based, which is on tethered, internet, optical fiber, and so on. So based on your hardwares and based on your needs and based on the data, you have a different communication technologies. So after you connect with them, your goal is to send the data to the cloud. So there might be different transportation protocol like IPv4, IPv6, which is layer 3 in the OSI layer. And layer 4, for the session layer, you might be using different protocol. For example, for your website, you're using HTTP, HTTPS. For file transferring, you're using FTP. But usually for IoT ecosystem in the industry, the most common one is MQTT and also COAP. So these are your communication level layer, which is on the technologies, layer 2, layer 3, and layer 4 of the OSI layer. Okay, this is layer 1. And then you are going for the presentation layer, means above, which is on the cloud. So when the data is sent to the cloud, the data is ingested in the cloud. That cloud can be local server or public cloud, means private cloud or public cloud or hybrid cloud. And you may have some database to store. So those database can be SQL based or no SQL based on the type of data. For example, if it's device data or human data, you can able to use MySQL SQL Server, which is SQL based database, or RDBMS, Relation Database Management System. Or if for the unstructured data, for its or semi-structured data of IoT devices, so there are different machine, different devices which are not in the form of a tabular form. So you can able to use NoSQL database basically. And then you are doing the processing, which is OLAP and OLTP. You may have a reporting, and you might be having 4 different kind of analytics, which we will able to discuss later, which is descriptive data analytics, which is we are identifying the patterns or trends based on the historical data. Okay, so those trends will be what WHAT will help you to understand what had happened in the past. The second, analytics and diagnostics, which is why it happens. And then you have a network management and other software that is serving your purpose for different application, either on consumer IoT, for home, lifestyle, health, mobility, or industrial IoT, which is on the business. So business IoT is an industrial IoT, which is also called IIoT for your retail, industry, healthcare, buildings, smart factories, smart cities, energy, services, and so on. So this is your technology and application, which are basically based on 4 layers, which is hardware, communication, software, and application. So that is an overview, bird's eye view of 4.0 technologies. Very short one, which is IoT, cloud, analytics, but we didn't went for AI, so we'll study more on that. So in the analytics, which is the 4th technology, so IoT is first, robotics is second, cloud is third, and data analytics is the 4th technology, which is on the descriptive and diagnostic analytics, where you have a visualization graph. So those visualization graph will able to help you in terms of understanding the live data and tells basically what happened in the real time before. And usually for this kind of analytics, you have a raw data. So you need to clean your data first to identify some anomalies, outliers, and you have to remove them. If there's some format issue, you need to standardize them. If there's some missing value, you have to predict the predict the right value using mathematical equations and statistics. And if there are some formatting issue, you will able to change the format based on the standard. So this is on the descriptive analytics side. So once you have done the descriptive analytics, then you go for the diagnostic analytics. So when you are basically having an ESG initiative, let's say for energy management, which we have taken in for the industry right now is quite much common. You do the descriptive analytics of what was the energy usage, which part, where, from when to when, and how it was being utilized. So you have those trends. For example, in a factory, in a production line, how much energy you have used in the common areas, in the office space. And one of the main contributor for the most energy consumptions are two in a factory. One is your machines, and second one is your cooling system or temperature system or air cons, because they are using the major part of energy. So the older legacy system of the centralized aircon doesn't have most of the time sensors. So by installing the IoT sensor, you can control the environment. So by controlling the environment on specific need, you can able to contribute on the reduction of energy. So your goal over here is to understand the usage of energy in different places in your organization. Okay. So once you have understand means what you have understand where was the energy usage, then you need to understand the root cause why we are using that much consumption in that particular areas of a factory, and then you do the root cause analysis and understand why those things are happening. Can we able to reduce the blueprint of that? Can we able to troubleshoot some issues? So for the root cause analysis, usually we also use analytical tools like Power BI, Spotfire, Tableau that provides some visualization like decomposition tree visualization to understand the root cause. So once you understand what and why, now it's time for you to look into predictive analytics. Like if you do the saving, you haven't implemented IoT yet, you only harvest the data for only, okay? That data can be through IoT or through sensors only, depending on the accuracy. So after you have the data for a couple of weeks, then you can able to predict how much control environment you can do using IoT to fulfill your ESG goal and how much saving you can make before we can able to do the mass implementation of the communication technologies and also analytics. So you have to understand for predictive analytics, your Power BI and Spotfire or other tools supports some integration of advanced languages. So descriptive and diagnostic doesn't use AI, doesn't use artificial intelligence. It usually use human intelligence. Human intelligence is HI. Okay. AI will be used in here, predictive analytics. So predictive and prescriptive analytics use AI, and you have to use programming language like Python or R to do the forecasting in your Power BI. Okay. So in here, you can predict with 95%, 97% accuracy that give you an idea how much value creation it has been made and when it will be break even using ROI and RODI. And at the end, it's a prescriptive analytics where you are looking into prescribing the actions out of it. So artificial intelligence used by predictive and prescriptive, there are a lot of AI enabled ecosystem, but The most common one that we use for predictive analytics is machine learning. So machine learning is basically is green over here. Using supervised machine learning, unsupervised machine learning, reinforcement learning, semi-supervised machine learning, transfer learning, and ensemble learning, even deep learning is part of the machine learning, which is traditional machine learning, can help you forecast based on the structured data. So those data, for example, will able to tell us about forecasting based on the current energy use, how much prediction you can able to have if you want to do some saving. So at the end, it's all about dollars and cents for the forecasting. Okay. For example, in the advanced level, we can able to use deep learning to differentiate on the uh, classification of the shapes, segment any defect, object detection, uh, optical character recognition, and anomaly detection, which you can able to have behavior understanding. So your chat GPT, for example, is using machine learning, deep learning, NLP, and also other kind of AI, including the LLM. So in traditional machine learning, the accuracy is not that much high in terms of unstructured data. Structured data, yes. Unstructured data, it has some limitations. It can able to check identification of the reading of the barcode or absence or presence of an object, and also robotic guidance. But for deep learning, we need to look into inspection. Now, why I'm showing you this slide? It is related to one use case that is contributing towards ESG, which I will discuss later. So in deep learning, you can able to do the defect detection, quality inspection. Now, why how it is related to ESG? Because if you understand the defect, if you identify, then you do the root cause, and your goal is to minimize the defect. Because once it is defect, it's been wasted in terms of time, energy, and materials, which are contributing towards your ESG ecosystem. So the goal is number one to identify through AI, and number two to do the root cause analysis to address that issue so we can minimize it. The goal is not to identify only, because if this is identification and we are not rectifying it, then no use. So the use will be to identify using AI and then rectify, going to the root cause before process, and going to the one step before the process, and understand which of the station have causes this issue and how we can eliminate to minimize the defect. After all, less defect means less wastage of resources, E, less wastage of the material, E, and social aspect, S, and then contribution to the circular economy is G. Augmented reality, for example, ESG is also part of S, social, which is upskilling your people for IR, for digital technologies, and how they can be productive. So if you can make your people productive, actually you are contributing to the S part of the ESG goal. So augmented reality, virtual reality, and merged reality is a technology where augmented reality can be used to increase the productivity of the technicians in the production line, where they don't have to read the manual and go back to the machine and again another read the manual and go back. These two flow can be reduced, increase the time. To reduce it, you can have augmented reality gamified steps of not only learning the new technologies or machines, but also doing the troubleshooting. So people process technology makes the factory smart, but the compliance are based on the ESG and how we can able to do that. Because when you are increasing the forecasting of accuracy using IoT, cloud, data analytics, and AI, especially specifically machine learning or deep learning, then you are increasing the accuracy of your ecosystem and you are reducing the operational cost. So that operational cost is contributing towards your ESG 4.0 ecosystem. We will discuss in detail later. Reducing the design engineering cost, inventory holding cost, because if you have mass production and you cannot sell it, wasted. Okay, wasted of resources, wasted of the time, cost, and money. Machine downtime reduction, which is through IoT enabled ecosystem of Industry 4.0, is also part of your environmental factor. Labor productivity or workforce productivity increase using those technologies is also contributing to your S part, where you are making your people productive. And at the end, the reduction of the cost of the poor quality is also affecting your E and S part of the ESG certification. So in summary on 4.0, I would like to mention end-to-end ecosystem that can able to help us understand how deep learning in manufacturing or AI basically helping us part of the things. Okay, so when I mention about deep learning in manufacturing, I'm mentioning about AI, which can cover machine learning in advanced ways. So on your middle part, you have environment sustainability, economy sustainability, and social sustainability. At the bottom, you are having your own product, which is sustainable connected process. You have equipments which are IoT enabled. You have a data driven industrial process for quality management, sustainable manufacturing process. You have a people that you understand their activities and also awareness and training program in align with digital landscape or 4.0 landscape, promoting the data literacy and also technology. And on the environment part, you have a computation power measurement and life cycle measurement. So the computation power management means that if you have a bad code written by your programmer or your software engineer, it will utilize more processing power. More processing power means more energy. So you need to have an optimization, optimized code in order to utilize the energy. They are connected with the integration of smart sustainable process with AI through IIoT. And then you have a data layer. So data layer, so IIoT is basically extracting the data from all those places, environment, people, process, equipment, product, and then giving to the cloud. So in the cloud, after storing, you have a smart process of environmental impact. You have a product location and product conditions. Apart from that, on the enterprise level, you have service record and quality sheet and failure rates. So how you can reduce it. And then in supply chain aspect of the things for your manufacturing or industry, you have a product pricing, supply chain activities, inventory level, or are having an emission through supply chain. So you have an activity log, real-time monitoring of your data that is enabled through IoT. So you can able to measure the activity and compliance for your ESG in the form of data-driven landscape. Now, after data, after IoT and data, you have an AI part. So in AI, you need to have a descriptive analytics and diagnostic analytics that I have mentioned before to capture the environmental impact and also manufacturing activity status. That what you will be doing, that we are doing in the descriptive analytics for the ESG. For the diagnostic analytics, why it happened, what are the cause and effect of analysis, examine the cause why sustainability performance has been reduced. So in that point of view, once you have descriptive and diagnostic, then we go for the predictive, which will be predict the parameter affecting on the ESG part for sustainability, reliability, and quality. And then from there, you are basically going for the last level of the advanced analytics, which is prescriptive analytics, what action needs to be taken. So that actions are based on the identification of the area where sustainability can improve on the product, process, and system level. And this is cycle. because new data, new environment, new things are coming in, and they have to examine descriptive, diagnostic, predictive, and prescriptive. Based on that, on your application level, you may have a different application to understand your sustainability aspect of environment, economy, and social, which is economy is basically your governance. So synonym for that one is governance. So on your ESG part, your product lifecycle management, design traceability using data, AI, and blockchain, application flow control using real-time monitoring, shorter lead to downtime using predictive analytics, remote assistance, and fault diagnostics are basically contributing on your E, S, and G part. So this is in terms of bird's eye view of manufacturing ecosystem. So now basically let's go more details. We discuss about technology and mapping of 4IR technologies in terms of for the ESG 4.0. But let's go more deeper into ESG part. So like I mentioned in my second slide, that ESG is a company-wide initiative which who everyone needs to take part. And based on my humble interaction with different organizations, many of us are basically contributing towards ESG, but we don't know. So these are some of the departments basically that are compliance or contributing towards ESG. So in terms of brands, where marketing and communication is also be part of the ESG because they are growing the awareness, repetitions, and sales. Means that if you have an ESG certification, it will assist your brand, reputation, and also your sales. Because in Western part of the world, they have a quite much benefit and loyalty-based system for those companies which are ESG compliant. So which certification for Industry 4.0 are also covering that? World Economic Forum, in collaboration with McKinsey, come up with the Lighthouse 4.0 certification that are basically they are giving to those factories that have implemented IR 4.0 technologies and have a success story to be shared. Now, those success stories are based on quantification in terms of RODI, that is measured in the percentage improvement. Okay. So the first level is to get that certification. Second level is proceeding with the ESG compliance certification. And the third level is to have an end-to-end value chain certification. So your brand and communications means can able to increase your revenue and also attributes. Your employee engagement, which is part of your S, if you are promoting DNI. So previously we are DNI initiative for different races. Now we are promoting DNI for humans and machine to work together, which is Industry 5.0. So Industry 4.0 is more on how we can able to have an autonomous ecosystem using AI without considering human factor. Industry 5.0 says that AI is good, AI is nice, but humans are even more better. So how we can able to harmonize smart ecosystem with collaboration between humans and machines, okay, which is Industry 5.0. And talent recruitment and retention, if you are doing a training towards digital transformation that are contributing to your ESG goal by making your factory smarter, you are actually contributing to your ESG, which is on the diversity, turnover, having a higher impact in terms of training. Of course, retention is an issue, especially in Malaysia, because when you are training employees, some of the US-based company cannot do the bonding of that. So as a result, some of the employee take advantage, and after getting upskilled, they will fly to another company. So in general, the awareness are basically, and also those skills which are helping, because those technologies are complementing ESG implementation. So if you are upskilling your people in terms of those technologies, you are basically fulfilling the ESG goal. Social aspect, for example, repetition, and also the document and goal domain is basically something which is also contributing, and sustainability aspect of your reputation, cost reduction, operating cost reduction, and risk reduction, and also reducing the carbon blueprint and less waste with using lean compliance, lean Six Sigma compliance are affecting and assisting in the ESG KPIs. So there are a lot of benefits of ESG as a whole. So streamline those regulatory compliance will help in terms of ESG performance. And it is also contributing on minimizing the risk of regulatory sanctions and also enforcement of actions. ESG can able to help reduce operating costs, for example, energy management and efficiency, material packaging, and also operating profit using IoT, cloud analytics, and AI-driven architecture and implementation can able to reduce the operating cost. In terms of better talent acquisition and retention, this is E. This is S, where you are improving the employee satisfaction, and also ethical and sustainable practices for your employees are basically part of the S. For better shareholder returns, because when you are implementing that and getting the leverage out of it, it is basically indirectly affecting your market value, performance, and financial aspect. And then that will make you earn customer loyalty, especially on the different part of the world. So impacting in the ESG 4.0, there are 5 areas that are impacting, and there are many use cases. So you have, for example, supply chain sourcing and logistics. You have circular economy, net zero energy emission, operations and maintenance, and also empowering workforce are the 5 areas that you can consider implementing to get the ESG enabled ecosystem for your certification later. So those use cases, for example, in terms of supply chain sourcing and logistic, they are use cases that you can able to implement. So supply chain sourcing and logistic means that how you can optimize supplier landscape and logistic system to increase resilience that I have discussed before, transparency and traceability to track and report on the ESG metrics. So how we do the transparency? Transparency means all of the activities across supply chain are being having a digital print, means that you are getting the logs or monitoring them and saving them in the cloud database. How it can be done? It can be done through IoT, because IoT enable ecosystem will able to have actions. Whatever actions the machines are taking for a different thing, it is recorded in the database. So that is transparency. It means that you can able to see and view all of the stations across your end-to-end value chain, and it is transparent to you because it is visible to you. Traceability means that I can able to go back from one end to another end in terms of understanding what had happened in the past. For example, if I scan a barcode of a manufactured packed item, I can able to have a traceability backwards until from what sources the materials were being sourced. Are those company ESG compliance? Is there any ethical or unethical practices been made to acquire those materials? When the materials was being transferred, or the fleet management was being used in your supply chain to source, was the financial obligation and taxation has been compliant? When the materials was being transformed or transferred from one country to this country, what was the date and time, which vendor was being used, whether the temperature that is being required for that particular material before it gets spoiled is being maintained, and when it is being reached to your warehouse, who have received it, and after that, who is managing inventory, which part was being manufactured, what time it was being packed and dispensed to the distribution center, and what time it reached to the market, and when you are basically using it. So all of this tracking or traceability can be happen using IoT, sending the data to the cloud where you're recording it, and AI for forecasting. And to maintain the data integrity, you have to use basically the blockchain in response to that. So these are some of the use cases that complement that supply chain sourcing and logistics. So one is basically digital sustainability twin simulation ecosystem. Before you implement, you simulate to understand the investment, understand the value, understand the possible risk. You do the logistic optimization. For example, if you are using fleet, if you do route optimization, how much time you will save, how much petrol or for oil you will save. For instance, now there is a diesel price up, how you can able to minimize the cost of the petrol using route optimization using data and AI. How much physical climate risk. So if you are saving the time and saving the road, so it is contributing to less pollution. How you can have a supply chain management and forecasting, how you can able to have an on-time delivery, how you can able to do a precise forecasting for inventory management, how you can able to have a transparency of your end-to-end ecosystem of supply chain and traceability, which I just explained, and how you can understand the risk mitigation using based on your descriptive, diagnostic, and predictive analytics. So those use cases will able to contribute towards your ESG metrics for ESG 4.0. Next is on the circular economy. Definitely, when you are having an innovation on the product design development in your manufacturing or remanufacturing, based on those initiatives, will able to help you in terms of reducing the product carbon footprint. You will have a life cycle analysis and development in a more optimized fashion. You will have a new process design for the innovation and virtual machine commissioning that are contributing to your circular economy. And then on the dimension of net zero energy and emissions, your main goal is how you can able to have efficient, low carbon energy system enabled by new Industry 4.0 solution to reduce the cost, to track emissions, and also accelerate the transition towards. So if your machines are producing the energy or basically contributing to the carbon blueprint, so you need to have a measurement. It will be not qualitative based, but rather than quantitative based. So it has to be data driven to justify the need. On so what are the use cases that you can able to implement in terms of that compliance of net zero energy and emission? One is a carbon accounting reporting. So those reporting will not be manual, it will be IoT enabled. Microgrid with the energy storage in a battery, power purchase agreement, industrial energy management. Power purchase agreement can also be your solar procurement, smart water management. So you can able to gauge how you can able to utilize your water and how you will reuse the water, how you will able to store the rainwater. Like in Malaysia, lot of rain. How we can store that rainwater instead of throwing in a drain? How we can reuse them? So there are some factories in US and also other parts that using the rainwater that can be utilized in your manufacturing facility. So that is also part of your ESG, and how we can able to have energy efficiency or energy management and continuous emission monitoring. I have discussed about the use case implementation step and roadmap for energy management and energy efficiency before just now. So those are the factors that you can able to look into on your net zero energy and emission. And then proceeding will be operations and maintenance. So in your predictive maintenance ecosystem of your lean Six Sigma enabled production line, how you can have an advanced visualization, control connected equipment. So advanced visualization means your predictive analytics dashboard. Control connected equipment means IoT enabled. Increase your efficiency, improve quality. Quality is basically how you can able to have a deep learning based quality inspection. So you can able to identify the defect and rectify it, and then through the better decision process. In the beginning, it will be human based, then it will be AI based. That will be tracking progress towards your ESG goal. So what type of use cases that you can able to implement for the ESG 4.0? It will be real-time asset performance monitoring and visualization, which for the predictive analytics, quality sensing. Using AI inspection model using deep learning, you can able to inspect the quality, and then not only inspection but rectification means that you will able to find the root cause, address the root cause, so this kind of a defect will not happen. Process optimization in terms of time and energy and efficiency, OEE effect, predictive maintenance, remote monitoring, and paperless operations. So if you're using paper, how we can able to use digital? Because paper is basically coming from the trees. Trees are part of the environment. How we can go from paper to paperless? How we can digitize the process? So first one is digitization, where you are converting the manual paper based to digital based, and then you will extract the data out of it, which is the digitalization. And then when you are performing analytics, it is digital transformation. Lastly, on the empowerment workforce, which is on your S part of the ESG, how you can empower workers on through technology, how technology can facilitate them learning new training, new technologies for your manufacturing ecosystem, operator training, work process analysis, virtual training, work instruction and systems using augmented reality, safety compliance, hazard alert. All those are basically part of your S in the ESG. So we are using ESG augmented reality in which you can able to um, look into a process, digitized process. So firstly, paper-based learning, they are thick manuals. You can convert into digital format. Second one is to use latest GPT technologies using LLM to have a knowledge management. And then third step, which is the last step, is on how augmented reality can able to assist in terms of learning and troubleshooting based on the energy management, based on the knowledge management. So there are different knowledge from different people. There's no documentation available. So when they leave the organization or retire from the organization, they are taking the knowledge with them. How we can use that knowledge, which is unstructured data, in dump it into a database, and your artificial intelligence large language model with the help of NLP, deep learning and machine learning can able to work and become a knowledge base. So you can have an internal GPT that can able to assist you in the knowledge management of the people, process, technology, and data. So anyone can utilize it and it can able to increase the productivity, profitability, sustainability, and ease of adoption for ESG. So these are some of the important use cases that we are considering design for your ESG 4.0 initiatives. But it is tailored towards manufacturing and automotive and supply chain because that is the title of the talk today, which is ESG 4.0, which is ESG in Industry 4.0. In terms of innovation, let's discuss about 8 innovation ideas or areas in manufacturing that can support enhanced ESG reporting. Okay, number one is on the Industry 4.0 and company culture pave the way for accelerating sustainability. Number two is reduce waste through edge AI. Now, let me give you a different view. Cloud is good, but of course, cloud is pay per use, and cloud uses data center. Data centers use enormous amount of energy. So instead of asking cloud to use AI algorithm run to run, so AI needs big data. Big data is stored in the cloud, and then they have to use enormous amount of processing. Why not we divide it? Let's say 50% on the edge gateway and 50% on the data center. In this way, it will reduce your OPEX and also reduce the carbon footprint because you are doing the pre-processing and you are doing important annotation for your data. And then you, after the pre-processing has been done on an embedded system or a gateway or private server, then you can able to give it to the cloud. So it will reduce your cost. Okay. Reduce waste through edge AI is basically edge is doing part of the work of cloud to reduce the cost. improve the well-being of the people and planet through digital tools. Instead of using papers, we can able to use digital tool that can help you not only in terms of digitizing the process, but also effective communication and collaboration. Real-time operational performance to unlock new value. We have discussed that, for example, AI quality inspection, predictive maintenance, and so on. And how sustainable data-driven decision making we can able to look into for the energy usage, energy management. So instead of blindly putting the solar panels, why not understand the energy need, energy usage, and then strategize energy reduction, and then on top of it, implement the solar panel based energy management. So at least you will able to reduce further the energy usage and also reduce the cost of the energy blueprint in a very effective manner. Number 7 is to automate calculation of the product carbon blueprint. So that is important because of net zero aspect. So you need to basically automate the calculation in real time. And lastly is your supply chain resilience using digital twin technologies. Okay, so let's have some the second last part of the presentation, which is on the case study. So I have selected some case study that can help you understand about ESG implementation. So the first case study is Henkel. Henkel is a German-based multinational chemical consumer goods company leveraging advanced digital technology to scale sustainability across its product network. They have initiated a pilot project in Spain focusing on eliminating labels, shorter innovation cycle, which are agile based, and tracking the product data to enhance sustainability and security. So their problem was high paper usage on the shop floor, which is contributing towards your E and S. Significant. Okay, you can understand E because it's paper. Paper are coming from the trees. But what about S? Because S is a social aspect. So paper-based will able to reduce the collaboration and communication between the stakeholders. So it is also part of the S. Significant product obsolescence due to inefficiency in innovation cycle. That was the second problem. Number third is high level of waste, energy consumption, CO2 emission, and water usage. Maybe you may have ring some bells because it's a common problem across every factory. And the goal is to reduce the waste, reduce the energy consumption, reduce the CO2 emission, and reduce the water usage. And then lastly, the need for improved planning and also monitoring from the distance. Okay. So in these are the problem, and they have solved the solutions by implementing digital twin, which is a cloud-based digital replica of the facility. So they are using pictures and video and created a virtual environment of the whole factory to simulate operations, how their operation looks like, to understand the energy need, also to understand how much sustainability and safety they may have a problem, and also what are the CO2 emission first. And then they will, using that simulation, they have come up with the actions to understand how they can reduce the energy, waste, CO2 emission, and then they went for the implementation. And then they implemented, for example, energy optimization using predictive analytics, using machine learning to understand the data and reduce the energy blueprint. And the ROI was enormous. For example, they have used 70% reduction of paper used, 35% reduction of waste, 60% decrease in total energy consumption, and decrease in usage of carbon dioxide, and 4% reduction in total water usage. Apart from water usage, they can able to use, for example, or we can able to use rainwater as a part of water usage. So you are reducing the water and also getting the water from natural or to reuse it. Okay, so this is the ROI in the Henkel, which is using digital twin and also energy optimization. So for that energy optimization, first thing is they have implemented IoT sensors just to harvest the data, but not to control. Number two, after they harvest the data for a couple of weeks to understand the energy usage using descriptive analytics. Then they go for diagnostic analytics to understand where are the main source of energy usage and is there any way to reduce it. After that, they have implemented the control environment for IoT and then understand the energy reduction and then also forecasting. And then they implemented the solar solution to basically produce some energy. So first step, reduce the energy. Second step is to contribute through solar panels, so have more energy. So overall, it will be a reduction in the energy blueprint. Okay. I will play this video, but I'm not sure that this can able to be played. Okay. I think my network is not allowing, so we can able to send you the link for that one. The next case study is on Johnson and Johnson Vision Care System, in which they are looking into end-to-end supply chain or value chain optimization. So Johnson Johnson is US-based multinational company, and they have a very vast portfolio in the healthcare industry as well, and they have implemented basically IR 4.0 technology for personalized customer experience, which is personalized CX, and also enhanced supply chain efficiency. So the problem they were having is synchronizing the physical supply flow with the fluctuating demand, because global economy is quite fragile. And in Industry 3.0, we are looking into mass production, where 4.0 is on demand based. So our goal is to have minimum inventory holding cost. So to ensure quick and flexible order, they wanted to basically increase the CX, customer experience, and also customer satisfaction, and also reducing the operational cost, which they have done using adaptive process control and vision system, which is using the utilizing of a digital performance and also smart material handling tracking. Okay, so the ROI was 30% reduction of operational cost, 10% increase in OEE, 99% fill rate in the line item and customer, and 15% increase of employee productivity. So these ROI are basically sort of the good things that not only we are impacting the ESG metrics, but also getting some dollars and cents saving, which is basically ROI or RODI. Last case study is basically on Unilever. So I have given for manufacturing, but it was also good to do for non-manufacturing. So Unilever is British-based multi-MNCs, and they have implementing optimizing algorithm to improve the quality and throughput of the factory, because if the algorithm or computer programs are not optimized, then they are using more resources. So they have a couple of problems. Two of them are production line efficiencies, having control issue problem, quality control, water consumption was huge, and then a need to boost OEE while reducing the waste and water usage. Something similar of the previous use case. So in addressing those problems, they have implemented cloud computing platform for their understanding of materials, material management, PLCs and ERP system, and then also coupled with the IoT embedded system to improve quality of inspection while cutting the cost of the waste and water consumption. So it's a hectic process. It's a roadmap, but what I can suggest is, instead of mass deployment, you can start with the POC first to understand the value creation of RODI. And lastly is a track and trace technology using IoT equipment, technologies like RFID that enables smart validation and also production control. So the ROI is basically 42% in terms of material waste reduction and 26% cost per ton reduction, and also 15% consumption of water reduction. So they are contributing towards ESG. Okay, so this is my presentation, and I will be open for Q&A. If you have any questions, I will be obliged to answer. Any questions? Either you can able to ask me or you can type on the chat area of Microsoft Teams.
Hi, Dr.
Hi,
Mohammed.
Doctor. Morning.
I'm Gunalan. Okay,
Okay.
I think someone
Would
else
you like
also
to
took. Uh,
would you,
I got a questions. In terms of the ESG compliance at the moment, I think one of the sector that has been not so prepared well is agriculture. I supposed to be because of we are still having many conventional way of approach. How the government should support this.
Doctor, can I ask a few questions?
okay. So I would like to request if you can introduce your name and also your organization. So the question that you have asked just now was based on agriculture. So can you please tell all of us your name and also your your affiliation?
Okay, I'm Gunali Shanmugam. I'm actually a veterinary officer in Ministry of Agriculture and uh, Food Biosecurity, Food Security, as well as I'm in charge for some projects as well as the ESG compliance. So my question is, how we can prepare in terms of ESG compliance in agriculture that lacking in terms of preparation or preparedness, because many of the farms or projects have been more conventional in the way of their approach. So, and what the government role will be from your side, from your views, lah. Take it up.
Okay, thank you very much for this question. Basically, uh, technologies are there to support the implementation of ESG initiatives. Okay, so if we categorize as five core technologies that can be applied in any sectors are number one, IoT, because those sensors can able to sense the particular environment conditions that can be helpful for us to get the data and understand how we can reduce it. Okay. Number two is cloud, where you will be saving the data that will later analyzed by number third technology, which is analytics. So we can understand the bigger picture using descriptive diagnostic and predictive analytics. And number four is artificial intelligence. So you need those four technologies in any sector by minimum. So in terms of agriculture, what I can able to, if I able to look into E, S, and G prospect. So in the environmental sustainability aspect, your first thing is to reduce the carbon blueprint reduction. How we can do that? By implementing precision based farming techniques. How we can do that? By implementing IoT sensors in your farm or in your agriculture to harvest the data like pH, temperature, and then also using the renewable energy source for your agriculture operations. So right now there are many government incentive and there are many stakeholders in Malaysia. For example, ITRAMAS for solar and others that you can able to source the solar panel on the energy usage. So agriculture may require energy. So first thing is you can able to utilize those solar panels for the light, for the energy, for the sprinkler water may require some energy. So convert from the direct source to solar panels. Number two, for the water management irrigation system, you can put some water sensors to understand the water consumption and how you can able to implement. This is very important. Implement rainwater harvesting and water recycling methods. So in Malaysia, there are a lot of rain. It's a tropical country. So one thing is how we can reutilize the rainwater and water recycling methods implementation in agriculture. Number three in E is on the soil health. So you are practicing crop rotation and also soil fertility. So one of the important aspect is how we can reduce the chemical fertilizer and pesticide. So by reducing the integrated pesticide management, we are contributing on an organic based thing, which are contributing to ESG. So ESG is not only in terms of technology, but also ethical practice, less use of pesticide, and also biodiversity. Now, let me go for the social aspect. how you can able to ensure that there are fair wages being given with a good working condition to the farmers. Okay, so there should be a platform that can be implemented. There will be no middleman, so farmer can able to directly goes to the consumer or businesses, get the free share, and also community engagement and food security. Lastly, on the governance aspect, how you can ensure that there will be a transparency and traceability by providing, for example, um, audit certifications and all of the things. For example, even if you go to the China, they are already doing all of their transactions using Alibaba Pay or something. How we can use less currency, more digital, that can able to help in terms of auditing and taxation, and also ethical practices for no child labor, supply chain from seed to market, and also promoting transparency and traceability. In terms of um, technology innovation, we must need to use IoT to monitor the health of the crop, condition of the soil, weather, and how we can do the forecasting. In terms of blockchain, how we can able to ensure the traceability aspect, but there are some challenges. Number one is cost, because if you wanted to implement the IoT infrastructure along with the server and cloud, you need to number one need a cost to procure those equipment. You need a system integrator to implement them. Then you need to have an operating cost of the cloud management. You need to upskill yourself or your people, or you need to engage company like us on the aspect of analytics for descriptive and predictive. So these are some of the challenges. I hope I answer your question.
Thank you, Dol. I think that's very clear in your approach. You know how the agriculture can comply is, but I think there's a lot of rooms to work with data analytics in terms of what you speaking about.
Yes,
Thank you, Dol.
yes, yeah, especially the crops yield. So you may need to have not only the monitoring data for the crops, but also about what was the yield output that you can able to predict, what type of fertilizers that you have to use, what type of compliance in terms of regulatory. Now, one of the biggest issue for the implementing of IoT is in some areas there are no network. So how you can able to use uh, technologies like LoRaWAN that can be implemented privately when there is no telco signals over there, so you can have the own network. So the technologies that are there in Malaysia, how to use them, you may need some expertise. Now those expertise will not come for free. There may be some grants available, but you need to look into how you can monetize those implementation. It's not only implementing the technologies without return of investment. And if there are some return of investment, how many months or year it will take? By the time it will take, maybe there will be another challenges. There will be new
Yeah.
compliance certification of ESG. So there are some challenges. So agriculture is quite important sector, but sadly the transformation is quite slow. Not only in this part of the world, actually in everywhere.
Thank you, Dol.
You're most welcome. Any other questions? There was another question. There's a question from Lee Peiling. Can you explain more of supply chain? How can do the better sourcing of ESG? Lee, can you please explain your questions a bit more so I can able to answer? While waiting for Lee Pei, is there any other question? Because there was another person who wanted to ask me a question. So based on this question, for example, how we can able to explain more on the supply chain for better sourcing. So there are a lot of, if I may understand your question, you are asking a question how you can source to the vendor that can able to help you in terms of resilience and transparency of your supply chain in order to fulfill the ESG initiatives and compliance and standards. So you can able to have a certification, right? Okay. So in this regard, you need to look into sustainability aspect. So my suggestion will be that don't totally depend on the vendor on the implementation, rather have a strategy of co-creation. So in co-creation means that you are upskilling your own people and also collaborating with the vendor. So it will be more sustainable approach because your people will able to grow in terms of knowledge base internally that can able to help you for long term. In terms of sourcing, those factors that you need to look into is on the reduction of the carbon blueprint. So if you are talking about supply chain fleet management, you need to ensure that route optimization has been done. So route optimization in a basic level is using Waze or Google Map. But what I'm referring is not this. What I'm referring is this that in some cases, uh, you may have different warehouses and different sourcing. So how you can utilize to save time and cost. Okay. And second thing is how you can ensure the health and safety compliance and transparency. So transparency and traceability require implementation of IoT ecosystem. So if you have a bigger fleet of supply chain, don't go for everything. You start small with a couple of trucks or lorries by implementing IoT ecosystem of getting the location of the fleet. Uh, in some cases, you may need to maintain a temperature, so you can able to maintain the temperature and other aspect to look into the visibility of the movement of your fleet. Also implementing your inventory management system, which are more on forecasting based, so you don't need to do firefighting. So in terms of governance, you can after implementing those technologies, you will able to fulfill the supply requirement and regulation in terms of transparency and accountability. And those data which is coming from IoT will help you in terms of um, data integrity for the standards, ethical sourcing, and risk management. Technology integration, I think blockchain will be helping you in terms of transparency and traceability, but blockchain will not able to help if there is no IoT and cloud itself. Okay, so IoT cloud blockchain is for traceability. For analytics means you have a data, you can able to have a descriptive and diagnostic analytics from your vendors or from you. uh, Actually, if you wanted to learn the analytics using Power BI, it may take 5 days only. So you may have a data. You can use that data from the Excel or other sources in your Power BI to create a dashboard to understand descriptive and diagnostic analytics. Okay. For predictive analytics, you can able to use vendors because it's bit advanced level because they will be implementing machine learning algorithm. But my suggestion will be you can use them in the beginning, but you can also upskill using HR to cop claimable program. There are many, including us. So you can able to have learning of Python programming and data science. So you can learn, apply descriptive diagnostic and predictive analytics. Those analytics will able to help you analyze and improve supplier performance and also understanding the potential risk in your supply chain. So you may need to have a collaboration initiative and strategy to co-create those initiatives in this regard. So it will be helping you in your repetition, risk mitigation, operation efficiency, and stakeholder trust. The challenges that I can think in this part will be cost of investment, little investment for your proof of concept and for pilot. Number two is to gauge the supplier. So there might be many suppliers, but you may need government incentives and so on. And number three is time and complexity to implement those systems, actually.
Uh, Doc, I just got one more question. Now, in terms of compliance, one of the things that need to be done, implement is auditing process, and we need auditors or those who are well versed with this particular field. So, what your view on that? Because I don't think so. I come across anything like this.
Audit, no matter which auditor you use, Big Four auditor like PricewaterhouseCoopers, McKinsey, Accenture, and EY, or local auditors from different sources, they need the data. So that data needs to come from manual sources or digital sources. So the reliability of that data will only be there if it is coming automatically from the system. From that automatic system are basically implementation of your IoT and analytics and blockchain. This means that if you have IoT ecosystem in your agriculture based value chain, and then you are getting the data, harvesting the data, saving in the cloud, and use analytics to wrangle, clean the data for analytics, and then you have a traceability for those data to ensure the integrity, then it will be easier for the auditor to look into the compliance and integrity. So in Malaysia, for instance, there are many auditors for that one. So if you use, let's say, if you have money, you can able to use the Big Four consultancy. But I think there are some auditors. I cannot name them over here, but maybe you can able to message me, and then I can give you some of the details of those auditors that can able to facilitate you in terms of not only auditing and compliance for ESG, but also beyond that.
Okay, Doc. Thank you. Thank you.
Any other questions? So there is a question in here. Is there any financial support or government initiatives in terms of implementation of the ESG? Yes, there is. There is basically National Energy Transition Roadmap. So Malaysia have allocated about 2 billion ringgit in that, where they are looking into investment in terms of green mobility, renewable energy, and carbon capture, utilization, and storage, which is called CCUS. Okay. Number two, tax incentives and financial support. So tax incentives, if you have implemented those initiatives, then you will be getting a tax incentives, basically, uh, which I think is quite good because reducing the tax and incentives basically can able to help you in terms of investment that you can able to implement for the scaling of those initiatives. Okay. Number three is basically on the biodiversity and renewable side. So there are some details from MITI and MOSTI. So I think my team can able to send to you about those details. But definitely, if you are local SME, there are some funding as well as incentive. But if you are MNCs or foreign companies, they have some tax incentive for you in terms of implementing those ESG initiatives. Any other questions? So just to give one more suggestion before we conclude, you don't need to basically implement in a bigger scale. You can start with a smaller scale. And for IoT ecosystem, let's say for agriculture or for manufacturing, you can able to have embedded system like Jetson Nano from NVIDIA or Raspberry Pi to do a POC or pilot first. So it will be costing you around 1,000 to 2,000 ringgit. In a smaller scale, you can able to implement those initiatives first to understand the value creation. And then if you see that the value creation is there, then you can able to start investing, but incremental fashion. Not So in one shot with agile incremental fashion. Okay, so there are thousands of tutorials available. My recommendation is basically if you want a GPU based embedded system where you can able to use IoT and edge AI, NVIDIA Jetson Nano is a good embedded system to start with. If you want to go for only machine learning, then I think you can able to go for the Raspberry Pi. But Raspberry Pi is not industry grade embedded system. So different environmental factor in the industry can damage the board itself. So you need a very solid kind of casing for that. But NVIDIA Jetson Nano is basically more good in terms of power and also resilience based on industrial environment. Okay, if there is no questions, uh, we will be sending you the slides, and there are some people who have asked some questions, so we will able to answer them through the email as well. So thank you very much, and best of luck to implement the ESG initiatives in your respective organization. Thank you.